This is very different for the next thing we're going to talk about. So now we're going to talk about the centroid, and you will see that the centroid, first we will of course talk about 3D objects because that's where we're coming from, but the centroid is actually a geometric property. So now let's start and analyze that. So the centroid is a geometric property. So that means independent of what the potato is made from, only the volume matters. So that means, as you can see here in the picture, I actually don't have a mass element anymore, but instead I have a volume element. And that is the only difference here. So very similarly, I can deal with 3D objects. This is a 3D object here, and this is as high as we go geometrically here. Of course, you can also do it in 2D and 1D, which we will do down the road. But we are purely dealing with geometry here. So we can say that similar to before, the coordinates of the centroid of a volume can be obtained by replacing or rearranging parts in the formula. So similar to before, similarly, the coordinates of the centroid which is a geometric property, can be calculated by replacing W or M by V for volume, or also A for area, or L for length. And so it is not a difficult formula, or once again, it's the very same formula. So we can now write down the formula for the centroid location, which is the one we really will need a lot in this class. And that is x bar is equal to the integration of x tilde d volume divided by the integration of all the volumes, which is just the total volume. Similarly, for y bar, I can take the summation of y tilde dv divided by total volume. And last but not least, z bar is equal to z tilde dv divided by dv. And so now I can clearly differentiate between the two physical properties, which are the center of gravity and the center of mass. We derived the center of gravity in very long lengths, and we then quickly moved it to the center of mass because it was just a rearranging of the formula. And then we moved to a geometric property, which is only dependent on the actual shape of the potato and has nothing to do with what it's made from. And so for us here in this class, that's mostly what we'll be dealing with. In fact, we will actually take it one further down. We will go down from d volume to d area, but the derivation is the same one. And you also might have to deal with it in 3D here and there. So that's completely derived now, again, for physical properties and for geometric properties. And hopefully the difference between the two is clear now.